Hi, today we're talking about relays. Not those little teeny weeny relays, not even those big chonka relays. Today, we're talking about those huge relays. I acquired those heavy fucks a while ago, and they are actually from like train switch thingy-majig machine. Their job was, until they got decommissioned, to ensure that trains don't crash. We're now gonna make it crash a lot. Not trains though. As you might already have guessed, I want to build a computer with those things. And you might now ask, but Mats, a computer is such a complex thing, how can you build it with 1, 2, 3, 4, 5, 6 relays? Well, joke's on you. First of all, I got a whole bunch of those, and second of all, we're gonna build a simple computer. So, first of all, we have a little problem. Those relays, they don't work properly when the box is lying down. The box needs to be upright like this for the relays to properly fall back into their resting place, because they're actually gravity powered. So the first thing I did, and I did that off cam because I am a perfect woodworker and I spare you the details of how fuckery that I got here. I built a little rack where those things go into. So let me show that real quick. The boxes, they have little latches on top here, and they have little ears here. And you can just take the box, slide it in with a little bit of luck and preservation. Oh, come on. And then push it in. So, and now it's in, and fully stays there. This is just a prototype, but this is just so I can have them on the table and have them work properly. Now, I am pretty sure you want to hear this thing click, so let's turn on the power supply. Let's give it some 48 volts, and let's hook up some power to those things. I'm gonna take you guys handheld mode again, because I have a GoPro, I can do that. After comments of the last video, I actually found a lamp. So now I can actually explain something with a little bit of light. I've hooked up power to this very relay, so we can now energize it and watch it work. It's also very funny how you can see the other relay jump every time it energizes. This is very funny. When I don't know if that gets more extreme if I hook it up to like a more bigger relay. Let's hook it up to that big relay. No, actually that doesn't jump. That makes that one jump actually. This one jumps a little bit. Whoops. This is funny. So, but you also have bistable relays. For example, this one. There are the armature. Those here are the armatures, and they have their own contacts here. But they also push up this huge contact here, like this huge contact here, and those contacts are connected with each other on the bottom, right? And now, so I can now push that up, and the whole relay moves, and now it's set, and now this doesn't do anything anymore. And now I need to push up this thing, and now the upper armature moves back and forth, and you can move them. So I now have like a rough concept. I've made a very rough concept how I want to build what. It's a very simple state machine because I want to build something like a Turing machine out of it. So I will go to the computer and explain to you what I have planned.
So hi, Editing Mats here. I wanna explain really quick what I'm building here. So you guys might not know what a Turing machine is. It's a theoretical concept that Alan Turing made in the 1940s of a computing machine that is capable of, I think, all the computing things that you could compute. The concept is that you have a long line of data on a stripe, and the little carriage that moves along that tape and can do an algorithm on that tape. So this whole machine is a very theoretical thing, with the requirement being that the tape has an infinite size and the algorithm can be infinitely complex. That's the only way you can achieve every computing problem with that Turing machine concept. It will also take basically an infinite amount of time considering the algorithm. You could basically put a World of Warcraft in a Turing machine. It will just more be like frames per month than frames per second. Anyway, in our design, I simplified the design to very much simple specs. We have 11 states. So the state machine can have a total of 11 states, not more. And we have a tape for the memory of right now 100 bits. But this is easily expandable, so if we will figure out that 100 isn't enough, we could put more. I am pretty sure that the 11 states will be the limiting factor, and that is a lot harder to expand. So yeah, this is more like a proof of concept than an actual useful computing machine. But at the end of the day, it's from relays, so it will just be more like a percussive instrument that can do computing as a side product. Hi! You're probably skipping this as a sponsor block anyway, but I'm here to announce my new partnership. I am now officially partnered with PCBWay. I'm very happy about that because it kind of gives me more options to do more projects in the future. You probably know PCBWay anyway, like they offer like everything. Look at all of this stuff you can do, like PCB making and PCB assembly and like CNC milling and like 3D printing and like just everything. It is insane what they offer, and they're even not that expensive. And also ordering things from them is super easy. You just press that button and then you go over there to like this quick order button right here, and then you just shenanigans and upload the Gerber file and you press order and you're done. It is literally this easy. And also, you know what's really cool? Look at that! I recently discovered they offer like super duper cool like UV printing. So you can make PCBs with artwork on it. Like, I will be using this service so often for my projects. Imagine what cool projects you can make with color prints on your PCBs. Isn't that crazy cool? I don't know what is. Anyway, thank you so much PCBWay for sponsoring this video.
The first step to get my whole like system running is to get all the system-wide signals up and running. And to do that, I need to like get some free relays. So you need to undo all the wiring, and that's what I'm gonna do right now. After a nice evening in the Discord, you can redo your statement about my micropenis once it's in your ass.
It's science. It's nano science.
Yeah, that's fine. No. You know, little children, right? When they learn by taking things into their mouth. Yana was different. He was learning by doing.
Oh my god.
By shoving up his ass.
That's what my uncle always said.
Link in the description if you want to join. Also, if you want to see the whole thing uncut, go to my Patreon. There will be a lot more of this shenanigans there. But I did not finish what I made the first step of the wiring in this first cabinet. I took you guys handheld mode. Just to explain a little bit, this is not used wiring, this goes to a capacitor. So, generally speaking, what happens is this is one of those state relays that I told you about earlier. And so basically what it just does, if it's enabled, this is, no, hold on. If it's enabled like this, it just connects those two wires to the other side, obviously. And those are basically the state wires that you can then patch. This is the relay that sets the state wires, and then those state wires need to be energized probably from this relay. Then the reset mechanism is also very simple. You have the reset wire here, that's the reset ring, that's just what connects all the reset wires together. And if the state set is like if those wires get energized, it energizes one of the other state, right? Those go up. If it goes up, it connects those two contacts together, which connect power through this wire to the red wire to the reset ring, which resets all the other states, like to stay with all the other states, except of this one, because this one is, because it's up, disconnected. So it's very simple. It's just a self-resetting state wiring. And so what I now want to do is I want to like build the impulse mechanism that impulses those wires. So every time that impulses the whole system advances. And I'm not fully sure how I want to do that yet. Because it needs to be slower than the mechanism that drives the switch mechanism, basically. I just figured out a small problem. I have now like hooked up the one relay. That's the relay that is making the clock. So like when I turn it on, it's gonna make the pulse clocks. But what I figured out, what is the problem, is you know, I forgot about the fact that relays, when they connect, right? So the idea that I had with those being a ring to all the relays doesn't work, because what I connected here is I connected the zero output, so the default state of this thing, to this relay and then this relay back. So what they should do is they should flip-flop all the time. But look what happens when I turn it on. And now that's an infinite state. So what just happened is this one got set, or actually this one was set in the first place. This one never got reset. This one got set, and what that should happen, you know, in an ideal state. Let me disable the clock real quick. I put a screwdriver in the relay, so now it shouldn't. Yeah, exactly. So in the ideal state, what should happen is this should enable and disable that, and then when this gets set, it should disable that. But that does not happen. Instead, what happens is this gets set, and then this gets set at the same time, and now suddenly, if they act exactly simultaneously, which they do, they disconnect the reset coil of the other side immediately, both at the same time, and then both can be on. And now they just clock because this is connected and this is connected, so both of the set coils are activated at the same time. So what happens when I take this out is they just jump like that. You need to reset one, and now nothing works anymore because the pulse is apparently too short for some reason. I don't know why it works in the beginning for a short while and then suddenly it doesn't anymore, because now it works. Like one time, I don't know. I don't fully understand it. Okay, actually, I figured it out. It took a lot of fapping and thinking and yapping and a lot of my Discord members. But essentially, I had the problem that the relays were resetting too fast. And it could happen that two state relays, which were latches, were on at the same time. So the computer could be in multiple states simultaneously, which is an invalid state of the whole computer, which then made the entire thing crash. That is bad, we don't want that. So what I did is the pulse that goes through the machine and sets the state is now governed in length by this relay. And this relay is set by the reset line. So basically, as soon as the relay switched to the point that the reset line is high, which means the state of the relays have changed, it turns this off, and thus turning the reset line and all the other settings off as well, which then also charges those capacitors, which I also added, which then holds the relay line on reset for a bit longer, which just is enough if both of the relays would be enabled, that the set relay will fall down first after the, or like first before the reset relay, which on this bottom latch here will then cause it to actually fall into the reset state. So that's what I added. I added one relay and two capacitors. I mean, three capacitors. And now I want to demonstrate to you. When I turn it on, the clock turns on. That's just the relay that hangs itself and repeats. That's good. This is the input relay that sets if the input state is 1 or 0, which at the moment is just 0, which is fine. And as soon as I set the state, one of the states, it doesn't matter which one, I can set the state, and now it switches state all the time until I reset. And now it doesn't. And now it doesn't do it again. It should freeze in a state. Isn't that satisfying as fuck? That is also a very interesting failure mode, and I have not yet figured out completely what the problem is, but again we have ended up in that failure state. I think that the capacitances on the capacitor is about not enough, and you can just fix it by holding down one of the states and it will reset one of the states. I just don't fully know what the problem is, pretty much. Anyway, that works, and I'm very happy about that. Ah yes, peace and quiet. But my first prototype of this whole machine is actually done now. We have accomplished the whole thing, because actually what have happened now, what you've seen is this is now basically a halfway working Turing machine, because it just executed code. The code was, or the algorithm of the Turing machine was, if this is state 1, this is state 2, for example, and this is the input relay. The input relay is off by default because it's not even hooked up. So if the input, or the tape is now basically hard written as 0 because there is no tape. If the tape is 0 and the first state is active, go to the second state. If the second state is active and the input is 0, go to the first state. And that's basically the algorithm that it just executed. So this is a working Turing machine with 2 states. Now, the next thing is to build the cabinet, the actual cabinet for those relays, and add all the 6 cabinets, because there are going to be 4 cabinets above it with then giving us 11 states. Add the little patch panel which goes about here, I believe, and then also add the stripe, or the tape, which will be another project. I hope you liked this episode, and if so, please consider giving it a like. If you haven't already, please subscribe. I have a Patreon and a Discord server if you want to join that and support me. And thank you so much for watching. I'm out. See you soon. Have a good one. Bye.